In the name of God, the most gracious, the most merciful, peace be upon you and God's blessing. My name is Magid Kamel and I am a civil engineer. We will start our discussion about the first case of Moore's circle of inertia, where Ix is bigger than Iy and Ixy is positive. What are the shapes that fulfill these two requirements? We have the rectangle shape with a dimension of b by h, where b is less than h. In the left corner, we have Ix equal to b multiplied by h cubed divided by 3, while Iy is equal to h multiplied by b to the power of 3 divided by 3. The product of inertia Ixy is b squared by h squared divided by 4. Similarly, for the case of a right angle triangle, the left corner will have an Ix value equal to b by h cubed divided by 12, while the Iy value is equal to hb raised to the third power divided by 12. The product of inertia Ixy is b squared by h squared divided by 24. We have two expressions for the inertia about inclined axes. The first expression is Ix dash equal to Ix plus Iy over 2 plus Ix minus Iy over 2 multiplied by cosine 2 theta minus Ixy sine 2 theta. The second expression is Iy dash equals Ix plus Iy over 2 minus, open bracket, Ix minus Iy over 2 multiplied by cosine 2 theta plus Ixy sine 2 theta. When will be Ix dash maximum? It will be maximum if cosine 2 theta b1 is positive and sine 2 theta b1 is negative, since we have positive plus positive multiplied by positive minus positive multiplied by negative. This means that 2 theta b1 is in the fourth quarter, where 2 theta b1 value is from 0 to minus pi over 2. In the normal view, theta b1 value is between 0 to minus pi over 4, represented by u. On the contrary, Ix dash will be negative or minimal when cosine 2 theta b2 is negative and sine 2 theta b2 is positive, since we have positive plus positive multiplied by negative minus positive multiplied by positive. This means that the 2 theta b2 is in the second quarter, where 2 theta b2 value is from pi over 2 to pi. In the normal view, the theta b2 value is between pi over 4 to pi over 2, represented by v in the normal view. In the next slide, let us investigate the condition of the equations of Ix dash, Iy dash, and Ix dash y dash when we have theta equal to 0 and 2 theta equal to 0. Ix dash equals Ix plus Iy over 2 plus Ix minus Iy over 2 multiplied by cosine 0 minus Ixy multiplied by sine 0 all equals Ix, while Iy dash equals Ix plus Iy over 2 minus Ix minus Iy over 2 multiplied by cosine 0 plus Ixy multiplied by sine 0 equals Iy. Ix dash y dash equals Ix minus Iy divided by 2 multiplied by sine 0 plus Ixy cosine 0 equals Ixy. In the next slide, let us investigate the condition of the equations of Ix dash iy dash and ix dash y dash when we have theta equals to pi over 2 and 2 theta equal to pi. Ix dash equals ix plus iy over 2 plus ix minus iy over 2 multiplied by cosine pi minus ixy by sine pi equals iy, while iy dash equals ix plus iy over 2 minus ix minus iy over 2 by cosine pi plus ixy by sine pi equals 2 ix. Ix dash y dash equals ix minus iy over 2 multiplied by sine pi plus ixy cosine pi equals minus ixy. These are the step-by-step procedures to construct Moore's circle of energy. Number 1, draw a horizontal axis representing Ix, Iy, Imax, and Iminimum. Number 2, draw a vertical axis representing Ixy in the upward position when Ixy is positive. Number 3, locate the point which has a coordinate of Ix, Ixy. Point A is drawn at the right side and with Ixy upward. Number 4, locate point B where a coordinate of Iy, minus Ixy. The point B is drawn at the right side and with Ixy downward. Join the 2 points A and B and cut the x-axis in point O. Number 6, draw the circle with a radius equals to OA equals OB. If we draw an axis parallel to the IXY axis passing by point O, it will be at the right of axis IXY with a distance of IX plus IY over 2. The coordinate of point O is Ix plus Iy over 2, 0. The radius of the circle is equal to the square root of Ix minus Iy over 2 squared plus Ixy squared. Point E is the maximum value of Ix and it equals Ix plus Iy over 2 plus capital R, while point C is the minimum value of Ix and it equals Ix plus Iy over 2 minus R. If we move to the next slide, we can find that line OE represents the x-axis in Moore's circle, while x OB is the y-axis in the Moore's circle. The angle between x and xy is twice the angle between x and y in the normal view. The angle in Moore's circle is 180 degrees. Now we can check our notice that for a maximum value of Ix, move to the 4th quarter or move clockwise with an angle of 2 theta B1. While the minimum value is obtained if we move anti-clockwise with an angle 2 theta B2 in the 2nd quarter, then angle 2 theta B1 is the angle between axes X and U axis, while angle 2 theta B2 is the angle between axes X and V axis. In the next slide, we create a mirror point A dash with a coordinate of Ix, minus Ixy. Why do we need that point A dash? Drawing that point will bring the x-axis into its normal position as the horizontal axis, while the major axis is rotated by an angle of 2 theta B1. The direction of axis U is now the line between O and A dash. The angle of 2 theta B1 is a central angle. In the next slide, we extend a line from A dash point to point O and extend to point B dash. The direction of the v-axis is the line OB dash. If we check the equation of tan 2 theta b equals minus ixy divided by ix minus iy over 2. Tan 2 theta b2 is the second quarter with a tan with a negative sign. Tan 2 theta b1 is in the fourth quarter with tan with a negative sign. 2 theta b2 equals to 360 minus 2 theta b1. In the next slide, we want to get the direction of the u-axis in the normal view and its angle. Join point C with point A dash. The enclosed angle is theta b1, which is half the value of the central angle 2 theta b1. In the next slide, we want to get the direction of the v-axis in the normal view and its angle. Join point C with a point B dash. The enclosed angle is theta b2, which is half of the value of the central angle 2 theta b2. In the last slide, when we first draw a Morse circle, we start to draw a horizontal axis considering ix, iy, and imax. We draw the ixy axis, which is perpendicular to that axis, and at the left of the vertical line passes by the center of the circle. Now consider the u-axis as your datum and modify the ixy axis by making it parallel to line OA, and at the left of the line OA by a distance of ix plus iy over 2. Now we have the x-axis is the horizontal axis. Check for theta equal to 0. We find the point E with a coordinate of ix, ixy. The OE distance is the radius r. The distance ix is measured from the ixy new datum, which is ix plus iy over 2 plus ix minus iy over 2, while the positive ixy distance is above the u direction. Check for theta equals pi over 2, then 2 theta equals to pi. Anticlockwise, we find point B with a coordinate of iy minus ixy. The OB distance is radius r. The distance iy is measured from the ixy new datum, while the I minus ixy distance is negative below the u direction. Thanks a lot and see you. Goodbye.